Hello everyone, welcome to Victory Batch. This is me Arvind Suthar. I welcome you all in this one short lecture on Binomial Theorem. I hope that your JEE preparation is going good and you guys are working day in and day out at this moment of time, because this is something which is definitely going to pay you back in terms of good results. So keep working hard at this moment. So today in this series we are talking about the topic binomial theorem. So let me tell you from JEE point of view, if you see this particular topic from JEE mains perspective, this topic is very easy and scoring, because the questions that will be asked from this topic as far as JEE mains is concerned is quite predictable in nature. One question will be coming from this particular topic in JEE mains, and as far as JEE advanced is concerned, so over here in JEE advanced, this problem is this chapter is a bit problem in terms of we see the JEE syllabus. So as far as JEE mains is concerned, this is quite easy, but the application part which is involved in the chapter as far as JEE advanced is concerned, so for that you need to do a bit of practice. Okay, yes, otherwise you can easily master this topic. There is not at all difficulty in order to master this topic. All right, so here we go towards our session, and let's talk about what exactly is a binomial theorem. So in binomial theorem you need to know this particular expansion, because if you know this particular expansion, then everything is going to be smooth for you. So let me explain this expansion in case you have any difficulties over here. So let's say we are having something like this. I hope you people know what is a plus b ka whole square, everyone. Yes, everyone out there knows what is a plus b ka whole square. It is nothing but equal to a square plus 2ab plus b square, right? Okay, if I ask you what is a plus b to the whole power 3, you know that it is a cube plus 3a square b plus 3ab square plus how much? Plus b cube. Yes or no? Or if I ask you what is a minus b ka whole square, you guys can definitely tell me that a minus b ka whole square is nothing but a square minus 2ab plus b square. If I ask you what is a minus b ka whole cube, you guys will definitely tell me that it is nothing but a cube minus 3a square b plus 3ab square minus b cube. Yes or no? Okay, now if I ask you what is a plus b to the power 4, you will be like, Ayla sir, this is a bit difficult because this is something we don't usually remember. I'll say, okay, if you don't remember this, then can you somehow calculate it? You will be like, yes sir, definitely. Either we can do a plus b into a plus b to the power 3, or we can also do it like this. Either we can calculate this particular thing in this fashion, or we can also calculate this particular thing in this particular fashion. Yes, both are fine by us. Now in whichever way you will do, you will get the same answer. I hope you can multiply these two things, and over here also you guys can multiply these two things and can get the answer, right? Okay, now if I ask you what is a plus b to the whole power 5, you will be like, sir, don't do this to me, sir, don't do this to me. It is going to be a bit more complex this time. Yes or no? So ultimately you guys can see that these expansions are quite easy, so you can remember them. But if we go towards a plus b to the whole power 4, it will be a bit tedious then. And if we talk about a plus b to the power 5, then it is going to be much more difficult after that, and so on if we proceed. And now if I ask you what is a plus b to the power 100, you will be like, sir, I don't want to prepare for JEE, I'm leaving it, I'm leaving this planet, right? So this kind of a thing will come into your mind if you haven't studied binomial theorem, because if you have already studied binomial theorem, or if you have a good idea about binomial theorem, then I think you will be able to understand that this thing is also going to be much more sorry, this thing is also going to be much simpler now. All right, so let me tell you the expansion which we use over here. So ultimately, why we do call this chapter as binomial? Binomial. Bi means two. Bi means what? Bi means two, and nomial means terms. So a particular thing having two terms. All right, observe over here. This is one of the term. This is another term. So there are two terms, right? A and B. So we are connecting them by using plus or minus. That's why we're going to consider these two as different terms. Okay. So this is one of the term, this is another term. So these are two terms involved over here, yes, and that's why we do call this particular thing as binomial theorem, because if the two expressions are having plus or minus in between and raised to the power any number is given, by the help of binomial theorem we can expand it. Okay, so let me give you the binomial expansion now. All right, over here let's say two terms are there, x and y, and we have connected them by, let's say, plus sign. We can connect these two terms by plus or minus as well. All right, so in order to expand this we will be using binomial theorem. So binomial theorem says that if you want to expand this particular thing, then over here first we write nc0, then nc1, then nc2, then nc3, and so on. We move towards where? We move towards ncn. nc0, nc1, nc2, nc3 till what? Till ncn. Okay. In each of these terms, what we do, we take x and y. We take what? We take x and y in each and every term. Okay. Over here also some x and some y. Over here also some x and some y. Over here also some x and some y. Over here also some x and some y will come. Okay, then what we do, whatever is the base of this c, whatever is written in the subscript of c, we assign the same power to y as well. Over here the subscript is 1, so we assign the power of y as 1. Over here the subscript is 2, so we assign the power of y also equals to 2. Over here the subscript is 3, so we assign the power of y also equals to 3. Over here the subscript is n, so we also assign the power of y as n. Now talking about the power of x, always the sum of the powers of x and y will be equal to n. Always the sum of the powers of x and y is going to be equal to n. So over here the power of x will be nothing but n. Okay, over here it will be n minus 1, because if you add these two, don't you think n is coming? Yes. If you add whatever is written over here, and if you add these two, you have to get n. So that's why over here the power of x is going to be n minus 2. Over here the power of x is going to be n minus 3. And over here the power of x is going to be nothing but equals to 0 only. Yes or no, everyone? And just add all these terms. Just add all these terms. What you get is nothing but the binomial theorem only. So what are the points that I have told you so far? First we're gonna start with nc0, then nc1, nc2, nc3, till where? Till ncn. Okay, so how many terms are written? This is one term, first term. This is second term. Like this, how many terms are written? Can anybody in the chat box tell me, everyone? Yes, this is third term. And like this, how many terms are written? This last term is going to be n plus 1th term. Which term? N plus 1th term. These are total n plus 1 terms. How, sir? Let me tell you this particular thing. Over here, understand, we are starting with a 0 subscript of c, then 1 subscript, then 2 subscript, then 3 is the subscript, and so on till we are moving towards n. So we are starting from 0, 1, 2, 3 going till n. That's why these are how many terms? These are n plus 1 number of terms. So in this expansion, the first thing that we have to notice is n plus 1. Total number of terms are how much? Total number of terms. Total number of terms is equal to how much? Is equal to n plus 1. If the value of n is given over here, let's say 10, the number of terms will be what? 10 plus 1, that is equals to 11. If x plus y to the whole power, let's say 100 is asked, then the number of terms will be equal to what? It will be equal to 100 plus 1, that is 101. I hope you guys are fine with this. Number 1. Number 2, if you see over here, number 2, if you see over here, in every term, summation of powers of x and y is equal to n. Understand, over here, if you add these two powers, is the summation coming out to be n? Yes, sir. If you add these two powers, is the summation coming out to be n? Yes, sir. If you add these two powers, is the summation coming out to be n? Yes, sir. If you add these two powers, is the summation coming out to be n? Yes, sir. If you add these two powers, is the summation coming out to be n? Yes, sir. So you can notice this particular thing over here as well. Understand? Over here a and b were the two terms given, and over here power 2 was given. So that's why n plus 1 number of terms, that is 3 number of terms were coming, number 1. Number 2, over here there is no b, that is it is nothing but b to the power 0. Okay, over here a to the power 1 and b to the power 1. Is the summation of these two terms coming out to be 2 or not? Is the summation of these two terms also coming out to be 2 or not? Is the summation of these two powers also coming out to be 2 or not, everyone? Why 2? Because it was asked a plus b to the whole power 2. If we are talking about a plus b to the whole power 3, then over here power 3 is written. So total number of terms is going to be 3 plus 1, that is 4. So this is first, second, third and fourth. Yes or no? Total 4 number of terms. Alright. In each and every term, if you see, the summations of the powers of a and b has to be what? Equal to n, that is equals to 3 only. So over here there is no b, that means the power of b is going to be 0. So if you add these two, what is the summation of the powers of b and a? It is nothing but 0 plus 3, that is equals to 3. Over here if you see, what is the summation of these powers? 3 again. What is the summation of these powers over here? 3 again. What is the summations of powers of a and b over here in this term? Again 3. Yes or no, everyone? So whatever is the power of, whatever is the value of n, the summations of the powers of a and b is nothing but equal to n. So you must keep this particular point in mind always. So this is nothing but binomial theorem. So x plus y to the whole power n can be rewritten as nc0 into x to the power n into y to the power 0 plus nc1 into x to the power n minus 1 into y to the power 1 plus nc2 into x to the power n minus 2 into y to the power 2 plus nc3 into x to the power n minus 3 into y to the power 3 and so on till ncn into x to the power 0 into y to the power n. Yes, these are total n plus 1 number of terms, and in each and every term the summations of the powers of x and y is nothing but equal to what? Is equal to x only. I hope you guys are clear with this. Okay, over here these particular things, what particular things? Let me tell you. Over here these nc0, nc1, nc2, nc3 and so on till ncn, these are known as binomial coefficients. These are known as what? These are known as binomial coefficients. These are known as binomial coefficients. There is a usage of all these things in the chapter permutations and combinations as well, but we do call these coefficients nc0, nc1, nc2 till ncn as binomial coefficients. Now I hope you know how to evaluate binomial coefficients, so let me tell you a formula over here. This is binomial coefficient NCR, and this can be written as n factorial upon r factorial times of n minus r factorial. Understand? Whatever is written over here, it is written over here, n factorial. Whatever is written over here, it is written over here. Then the subtraction of these two numbers, that is n minus r, is also written over here in terms of factorial. I hope you know what exactly is a factorial thing. We have already discussed this. 1 factorial is nothing but 1. 2 factorial is nothing but 1 into 2. 3 factorial is nothing but 1 into 2 into 3. 4 factorial is nothing but 1 into 2 into 3 into 4. 5 factorial is nothing but 1 into 2 into 3 into 4 into 5. 6 factorial is nothing but 1 into 2 into 3 into 4 into 5 into 6. 7 factorial is nothing but 1 into 2 into 3 into 4 into 5 into 6 into 7. 8 factorial is nothing but 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into no till it, and so on. I hope you got the logic what exactly is a factorial. This can also be represented by the symbol like this. This is also factorial 1. This is also factorial 2. This is also factorial 3. This is also factorial 4. This is also factorial 5. This is factorial 6 symbol. Okay. Factorial 7. This is factorial 8. Okay. Yes. You must remember few of the factorials as these are very basics like this, 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 and this. You must remember at least these values because they are very important. I hope you know few of the tricks to evaluate NCR comfortably. Let me give you, let's say we want to evaluate 7C2, then this is nothing but 7 factorial divided by 2 factorial into 5 factorial, because 7 minus 2 is going to be what? 7 minus 2 is going to be 5 factorial only. Understand? This is going to be 1 into 2 into 3 into 4 into 5 into 6 into 7, and this is going to be 1 into 2 into 3 into 4 into 5. So don't you think that 1 into 2 into 3 into 4 into 5, all these terms will be cancelled from here, and what we will be left out with is nothing but 6 into 7 only? Yes, and in the denominator 2 factorial is also written, so we can write it like this and we can evaluate the value, so it will come out to be nothing but 21 only. Again, I'm telling you, if you put the value of 7 factorial from here over there and 5 factorial from here, then you can see that 1, 2, 3, 4, 5, all these will be cancelled in the numerator and denominator, and you will be left out with this particular thing, and accordingly you can calculate the value of NCR. Okay, so you must remember this particular property as well. Let me tell you a very important property for NCR. I hope you guys know this. Very important property for NCR, and that is what? NCR is equal to NCN minus R. NCR is equal to what? NCR is always equals to NCN minus R. So there can be usage of this thing as well, which we have already studied. So let me quickly take you to binomial theorem now, and let's discuss all these concepts. So we have seen that x plus y ka whole power n can be written as what? Number 1. Number 2, where NCR is what? NCR is nothing but n factorial upon n minus r factorial times r factorial. Okay, and these are known as binomial coefficients, as we have already seen. The value of r goes from 0 till n, and n has to be a natural number. Here n has to be a natural number, or a whole number rather. N has to be a natural number. Let me write it like this: natural number. I hope you know what is a natural numbers: 1, 2, 3, 4 and so on. Okay? Alright, so these are the basic properties of binomial coefficients. Number 1, we have just seen that NCR is equals to NCN minus R. So let me explain you this property as well. NCR equals to NCN minus R. Okay. Yes, you can quite comfortably prove this because we have seen the formula for this particular thing. So what we do is we first write down whatever is written over here, its factorial, okay, divided by what we do is whatever is written over here, let's say whatever is written over here, we write it down, its factorial is what we write it down. So let's say we have written it like this. Then the subtraction of these two things, so n minus 1 r factorial is what we write, right everyone? Yes, okay. And if we talk about this thing, so over here n is written, so we're gonna write down n factorial. Okay, over here n minus r is written, so we're gonna write down the factorial of n minus r. Okay, then the subtraction of these two things is what we're gonna write down. So it is going to be what? N minus r and uska pura factorial, the complete factorial of that. So this thing upon simplification is going to be what? This thing upon simplification is going to be n factorial upon n minus r factorial times r factorial. So this is what? These two terms are equal, yes or no? This is our LHS and this is our RHS. So LHS equals to RHS, therefore LHS equals to RHS, that means hence proved. Okay. So if you see the usage of this property, let's understand the usage of this property. Number 1, if you talk about an example 18C2, let's say 18C2 will be equal to what? If you use this property, everyone, NCR equal to NCN minus R. Can you do this? It will be equal to nothing but 18C16. Yes or no? Okay. If you talk about 9C4, this will be equal to what? Can anybody over there tell me 9C4 will be equal to 9C what? 9C4 will be equal to 9C what? Apply this property and tell me 5. Yes or no? Let's do one more example. If we talk about 10C5, this will be equal to what? It will be equal to 10C5 only, sir. I said okay. Okay, 10C3 will be equal to what? Can anybody tell me? By using this property, 10C3 will be equal to 10C7. I said okay. If we talk about 9C1, 9C1 will be equal to what? 9C8. I hope you guys are fine with this particular property, that is NCR equals to what? NCR equals to NCN minus R. Clear everyone? Okay. Talking about this second property, let's talk about this property. This is property number 1, this is property number 2. That is NCR plus 1 equals to n plus 1 CR plus 1. Now understand this property over here. Understand this property over here. The second property is NCR plus NCR plus 1 is equals to N plus 1 CR plus 1. Understand this particular property, we can prove it, but rather than proving, our major agenda over here is to understand how to apply this particular thing in the problem solving. So here we go, let's understand this particular thing. Alright, yes. Over here you have to notice a few things, okay? And notice what? Look, these are same things written. These are same things written, and if you see at these two terms, the difference between them, the difference is of 1. Yes or no? The difference is of 1. If you see the difference between r and r plus 1, what is the difference? The difference is nothing but r plus 1. I said okay. Whenever these two things are added, having these pink things same and the difference between these two being 1, then this formula is applicable. This formula says that the summation of these two things will be equal to what? Over here, you're gonna write down the bigger term out of r and r plus 1. What is the bigger term? R plus 1, isn't it? Bigger term out of r and r plus 1, that is obviously r plus 1, yes or no? So out of these two terms, whichever is bigger, you're gonna write it over here, number 1. And number 2, what you're gonna do is you're gonna add 1 to these n's, add 1 to the value of n, Let me give you an example so that you can understand it in a better way. Okay, yes, let me give you an example. If I'm talking about what is 7c2 plus 7c3. Now understand, is this formula applicable over here? Okay, let's understand these two things are same and the difference between these two things is nothing but 1. So obviously this formula is applicable. Now what does this formula say? This formula says that add 1 to these values. If you are adding 1 to this, what are you gonna get? This is nothing but 8, and out of these two, which one is bigger? 2 and 3. 3 is bigger, so this value is nothing but going to be this only. You can individually calculate this value as well. You can calculate it like this: 7 factorial divided by 2 factorial and 7 minus 2, that is 5 factorial. You can individually calculate this as well: 7 factorial divided by 3 factorial and 7 minus 3 is what? 4 factorial. You can evaluate this value, add these two, ultimately the value will come out to be equal to this only. Okay, but if we know this formula, then we can directly write down the answer of this equal to this only. So that is what the intent of learning this particular thing is. I hope you guys are clear with this particular thing. So over here in this formula, two things are there. Above C, the terms written are same, that is the value of n, same, 7, 7. Then the difference between these two white things is nothing but 1, then this formula is applicable, number 1. And number 2, how does this formula applies? This says that over here we're going to write down one bigger term, that is 7 plus 1, that is 8 is what we're going to write down, and out of these two, whichever is bigger, that number is what we write down over here. So out of 2 and 3, which one is bigger? 3 is bigger, so that's why we have written 3. Okay, let's take more examples based on this. If I talk about what is 8c5 plus 8c4. What is 8c5 plus 8c4? Can you tell me directly by using this formula, everyone? Yes, same things over here, and the difference between these two is nothing but 1, so this formula is applicable. And what we do is 8 plus 1, that is 9. C, out of these two, which one is bigger? 5 is bigger, so let's write it down over here. I hope you people understood this particular thing. Now this formula is going to be very helpful if we are talking about calculations in this particular chapter, so that's why we guys are studying it. Okay, if I talk about what is 100C51 plus 100C52, the value of this is going to be what? It is going to be 101C52. Yes or no? Let's talk about more examples. If I talk about before that, let me quickly tell you a few things over here. Before that, let me give you some things over here. Remember, you must remember these things. The value of NC0 is always equals to 1. The value of NC0 is always equals to 1. You can calculate it by formula as well, because if you apply the formula over here, it is going to be n factorial divided by 0 factorial and n minus 0 factorial. By the way, you must know this also, that the value of 0 factorial is nothing but 1. This is an exception which you can understand through the topic permutations and combinations. The value of 0 factorial, is nothing but what? The value of 0 factorial is nothing but 1. Must remember. The value of 0 factorial is not 0, the value of 0 factorial is nothing but 1. Basically, this explanation comes from the chapter permutations and combinations. In case you have already studied this topic, then let me tell you that if you have nothing and you have to arrange them at no place, then in how many ways you can do that particular task? You can do that particular task in one way, that is, you don't do anything, right? Yes, that's why 0 factorial is nothing but 1. Okay, yeah. Okay, so the value of nc0 is always equals to 1 irrespective of the value of n. So if I talk about what is 1c0, what is 2c0, what is 3c0, what is 4c0, what is 5c0, and so on, they are all equal to what? They are all equal to 1 only. All equal to 1 only. Now, sir, why are you telling this property? We will come back to this page so that you guys can feel it. Okay, if I am asking you what is 4c0 plus 5c1, now here in this expression also you guys can apply this particular property. In this expression also you guys can apply this property. Sir, how come the value of nn is not same? Then how can we apply this property? All right, do let me know, since 4c0 is equal to 5c0, yes or no, equal to 1? nc0 is always equals to 1, yes or no? So we can write down the same expression as 5c0 plus 5c1, yes or no, everyone? Do let me know. And now, can we apply the formula over here? Yes, sir. So it is going to be what? 6c1. You understood this or not, everyone? Do let me know. Yes. So what can happen is that you need to apply this kind of this formula multiple times in the problem as well. Let me give you a problem like this: 4c0 plus 5c1 plus 5c2 plus 6c2 plus 7c3 is equals to what? Understand? The same problem can be written as 5c0 plus 5c1 plus 6c2 plus 7c3. The moment you apply this formula in these two terms, can you write down this particular thing as 6c1, okay, and then writing down these pink expressions as it is, 6c2 plus 7c3. Now if you apply the formula over here in these two terms, can you write down the similar thing as 7c2 plus that pinky ponky thing, that is 7c3, and ultimately this expression is coming out to be what? This expression will be coming out to be 8c3. So this is the final answer. Yes or no? Are you guys clear? So sometimes what happens, this 1 is written over here so beautifully that you may need to apply the value of nc0, that is, be it 1c0, 2c0, 4c0, 5c0, 6c0, they are all equal to 1. So this 4c0 can be written as 5c0, and then you can apply this formula so many times in the problem, and you can simplify this expression just like in a matter of few seconds only. I hope you guys are clear with this particular thing. So this is what property number 2 is, and I hope you guys are clear with this. Now talking about the third property, kids, here we go. The value of NCR upon NCR minus 1 is something like this. Let me give you an explanation, or how to remember this particular property rather, because more than seeing the proof of this problem, so this property, it is more essential that we know how to understand, how to apply this particular problem. We should know how to apply this in the particular problem. Okay, so the formula is going to be something like this. Now this is one result which you can prove quite clear easily, because NCR can be written as n factorial upon r factorial n minus r factorial. This is our numerator, and the denominator will be n factorial divided by r minus 1 factorial. Okay, and then n minus r plus 1 factorial, and you will cancel out the terms, and eventually you will reach out to this formula. So the proof is as easy as anything, but let me tell you how to remember this property and how to apply this in the problem solving, because that is very crucial part over here. Over here, look, these two things are having same n, yes, okay, number 1, and number 2 over here, if you see, the difference between these two terms is nothing but 1. Difference is of 1. difference is of 1. Okay, so understand this particular thing, that whenever this happens, this formula is applicable. Same things, and these are same things, and the difference between these two terms is of 1. Okay, so this formula is applicable. Now, how to apply this formula? Out of r and r minus 1, which one is bigger? Out of r and r minus 1, which one is going to be bigger? R is going to be bigger, yes. So in the opposite of that r wala term, we have written r. In the opposite, cross multiplication kind of a thing. Okay, so since out of r and r minus 1, which one is bigger? R is bigger. So in opposite of this particular term, we have written r. Okay, then in the opposite of this, what we are going to write down? The difference of these two things. If you do n minus r minus 1, it is going to be nothing but n minus r plus 1 only, and that is what written over here. I hope you people understood this a bit. Let me give you an example so that you can understand this in a better way. Example, let's talk about this. If I talk about what is 7c4 upon 7c3, then you guys can say that since, sir, over here same things are written, and the difference between these two things, this one and this one, is nothing but of 1. So this formula is applicable. I said okay, fine, not an issue. Out of 3 and 4, which one is bigger? Sir, 4 is bigger. I said if 4 is bigger, then what we're gonna do is opposite to this, we're gonna write down 4 in the cross multiplication kind of a side. Okay, yes. Okay, number 1. And in the opposite of this smaller one, what we're gonna write down? The difference of these two. The difference of these two is going to be nothing but this. I said fine, okay. The difference of these two, again I'm telling you, the difference of these two. So it is going to be 4 by 4, that is equals to 1. Oh, 7c4 and 7c3 are both equal. Yes, because you know NCR equals to NCn minus R. NCR equals to NCn minus R. So with the help of this property also, you guys can feel that NCR and NCn minus R are equal. So 7c4 and 7c4 and 7c3 has to be equal only. So the ratio of these two numbers is going to be nothing but equal to 1 only. I said fine, alright, let's move ahead. If I talk about what is the value of 15c3 over 15c4, then you can say what? You can say that, sir, these are same terms written, and the difference between these two is nothing but 1. So this formula is applicable. I said okay, out of 3 and 4, which one is bigger? Sir, 4 is bigger. So opposite to this term, what we're going to write down is that opposite term. So over here we're going to write down 4, and opposite to this, what we write down is the difference between these two numbers. So 15 minus 3 is what we're going to write down. Yes or no, everyone? Yes, sir. So let me write down 15 minus 3 over here. So it is nothing but 4 upon 12, which is nothing but equal to 1 upon 3. So understand, if we know these formulas, we can evaluate the value of this particular thing in a very short span of time. Yes or no? Are you guys clear with this particular formula, everyone? How to apply this? Yes or no? All of you guys do let me know. Yes? Okay. I hope you guys are clear with this particular thing. Okay, moving ahead towards this, that whenever NCR equals to NCY, either these two things will be equal. NCX, let's call it as X. Whenever NCX is given equal to NCY, then either two things can happen. Either X and Y will be equal, because N and R obviously same. Or if you apply this property NCR equals to NCn minus R, you can say that the value of X plus Y is nothing but equal to N. You must remember this as well. I hope you guys are clear with whatever we have learnt on this particular slide, and I hope now you guys are clear how to apply them even in the problems. Okay. Now, this slide is something which composed of all the important expansions which you can use in this particular chapter. So let me give you a brief explanation of all these things. Okay. So far we have seen that x plus y to the whole power n is equals to what? nc0 into x to the power n into y to the power 0. This is first term, plus nc1 into x to the power n minus 1 into y to the power 1, plus nc2 into x to the power n minus 2 into y to the power 2, plus nc3 into x to the power n minus 3 into y to the power 3, and so on till ncn x to the power 0 into y to the power n. These are how many terms? N plus 1 terms. In every term, if you see the summation of the powers of x and y, it is going to be nothing but equal to 1 it is going to be equal to n only. Okay, if I talk about what is the expansion of x minus y to the whole power n, then you don't need to worry because you can write down the similar thing like this as well, everyone. Then in this formula, in place of y, what you can put is nothing but minus y. So the moment you do this, you're gonna get something like this. Yes or no, everyone? You're gonna get something like this. Till what? Till ncn x to the power 0 into minus y to the whole power n. If you look at this expression closely, then over here you can write down this expression as it is, nc0 into x to the power n into y to the power 0 only, because this is nothing but ultimately 1 only. I said okay. Over here this thing will become what? Understand, this thing can be rewritten like this as well or not, everyone. Yes, if we talk about this particular thing, then don't you think that this particular expression will be written like this, because minus y ka whole square will become y square only, and so on the things will proceed. Yes or no? And at the end what you're gonna have is something like this, ncn into x ki power 0 into minus 1 ki power n into y ki power n. Can we write down this similar expression like this as well? Understand? Yes or no, everyone? If yes, now there is something very important over here. Over here, if you notice in the first line, if you notice, all terms are there with positive sign. All terms are with plus signs only. Yes? All terms are with plus sign only. Look, over here also plus is coming, over here also plus is coming, over here also plus is coming, over here also, and so on, over here also. So all the signs are coming up with plus. Okay, all the terms are coming up with plus signs. Over here if you see, this is x minus y to the whole power n. Over here if you see, alternate plus minus signs are coming. Alternate plus minus signs will come. Yes or no? Let me tell you this. Over here nothing is written in front, so it is plus only, then this is minus, then this is plus, then minus, and so on will come. Okay, over here if you write down one more term, if you write down, let's say, one more term, then it is going to be what? Let me write it, minus nc3 into x to the power n minus 3 into y to the power 3. Yes or no? Yes, let me write down this positive term over here with this only, nc2 into x to the power n minus 0. Okay, sorry, nc0 into x to the power 0 into minus y to the power 1. Sorry, 0. Wait. This is going to be n and this is going to be 0. Okay, yes. So over here alternate plus minus signs are coming. Can you guys feel this? Now this is something very crucial. This is something very crucial. Let's call this particular thing as 1 and let's call this particular thing as 2. If you add these two, something good will happen. If you subtract these two, something good is also going to happen. So if we add 1 and 2, add 1 and 2, on the left hand side it is going to give you something like this, x plus y to the whole power n plus x minus y to the whole power n is equals to twice of nc0 into x to the power 0 into y to the power x to the power n into y to the power 0 plus nc2 into x to the power n minus 2 into y to the power 2 plus nc4 into x to the power n minus 4 into y to the power 4, and so on. Whereas if you subtract 1 and 2, if you subtract 1 and 2 on the previous page, let me show you as well. You're gonna get something like this, x plus y to the whole power n minus x minus y to the whole power n is equals to twice of nc1 into x to the power n minus 1 into y to the power 1 plus nc3 into x to the power n minus 3 into y to the power 3 plus nc5 into x to the power n minus 5 into y to the power 5, and so on. Yes, now what are the things to notice over here? Let me tell you that over here every time the subscript of c is coming out to be an even number. always an even number, always an even number. Whereas if you see the subscript of all these terms, over here the subscript is always what? Subscript is always an odd number. This is something very crucial. Understand it from the previous page. Over here, if you add these two terms, don't you think that this term and this term will be added? This and this will be cancelled, yes or no? This and this will be added 2 times, it will become now. So ultimately over here, this 2 times of all the numbers with even subscript will come, and whenever you subtract over here, all 2 times of all the subscript with odd terms will come over here. Now this is very important thing, because JEE has asked a lot of questions based on this particular thing. JEE asked a lot of questions based on this. Let me give you an example how JEE does ask questions based on this. So let me give you an example over here, kids. Example. If I ask you root 3 plus 1 to the whole power n minus root 3 minus 1 to the whole power n, what kind of a number it is going to be? What kind of a number it is going to be? Or let's say it is 2n. Okay, let's say the power is 2n, not n. Okay, the question is what? The question is what kind of a number is this? Okay, so we know that if we do subtract this, then it is going to be what? 2 times of all the subscript with even numbers or odd numbers. We are subtracting it. All the subscript with odd numbers will come. So over here it is going to be 2n c1 root 3 to the power 2n minus 1 into 1 to the power 1. Okay, plus 2n c2 into root 3 to the power 2n minus 3 into 1 to the power 3, plus 2n c5 into root 3 to the power 2n minus 5 into 1 to the power 5, and so on. Terms will come. Now is this a real number? Okay, is this a rational number, irrational number, or what? Don't you think that this number is going to be irrational? Why irrational? Because root 3 to the power odd number is written. Odd number is written. If root 3 to the power even number aa jata, then the problem, this expression would have been a rational number. Yes or no? So this is also an odd number, so this term is also going to be irrational. So don't you think that the overall term is going to be nothing but an irrational term only, or irrational number only overall? Yes. Rather, if you are having a plus sign over here, then 2n c2 root 3 to the power even number, 2n c3 root 3 to the power c4 c2, yeah, 0 c0 c2, then over here also even power. In that case, the problem, the expression would have been rational number or not. Think over it, everyone, all of you. This is just one very basic example I have given you, so you must remember these things, as these are very important. Remember, there is no choice, you have to remember this particular thing, so that you guys can solve the questions in a relatively shorter time. So far we have seen this, we have seen this, we have seen this, we have seen this. Now talking about all these 4 things which are also similar to this only, so let's talk about all those things now. Okay, now this is something very important. What exactly it is? It is 1 plus x to the whole power n. The idea is same, nc0, nc1, nc2, nc3, and so on till where? Till ncn. Okay, then over here also in each and every term 1 will be holding some power, x will be holding some power, 1 will be holding some power, x will be holding some power, 1 will be holding some power, x will be holding some power, 1 will also be holding some power, x will also be holding some power, and so on. Since this is the later term, remember x plus y to the whole power n, y was holding that power which was written as the subscript of c. So over here this thing will happen with x. So the power of x over here is going to be 0, since 0 is written over here. The power of c, the power of x over here is going to be 1. The power of x over here is going to be 2. The power of x over here is going to be 3. and so on. Over here the power of x is going to be n. Yes or no, everyone? And in each and every term, the summations of the powers of x and y, or over here the powers of the summations of the powers of 1 and x will always be equals to n only. So over here n will come, over here n minus 1, over here n minus 2, over here n minus 3, and so on till this, and just add all of these things down. So this expression will become what? Let me tell you that this expression upon simplification will become something like this, because 1 to the power anything will become 1 only. So this is going to be nc0 plus nc1x plus nc2x square plus nc3x cube plus nc4x to the power 4, and so on till ncn into x to the power n. So you must remember this thing as well, that 1 plus x to the whole power n, that 1 plus x to the whole power n is nothing but equal to this particular expression. I hope you guys are fine with this. Remember, if on a similar basis we want to remember 1 minus x to the whole power n, 1 minus x to the whole power n, then over here in place of x we need to put minus x. So over here no x is there, so nc0 will come as it is. Over here, if in place of x if you put minus x, it will become minus nc1x. This will become nc2x square only, because the minus x ka whole square will also be x square only, that's why. Over here minus nc3x cube, then over here nc4x to the power 4, and so on you're going to move, and ultimately it is going to be something like this. Yes or no? Because this thing can be rewritten as 1 plus minus x ka whole power n. So in place of x over here, just replace by minus x to get this particular expression. Now calling it as 3 and calling it as 4. If you add 3 and 4, something good is going to happen, and if you subtract 3 and 4, something good is going to happen. If you add 3 and 4, what you're going to get is 1 plus x to the whole power n plus 1 minus x to the whole power n is equals to twice of all the terms with even subscript or odd subscript of c. Everyone do let me know. Even subscript of c, yes or no? So this is what you're going to get. And if you subtract 3 and 4, if you do 3 minus 4, you're going to get 1 plus x to the whole power n minus 1 minus x to the whole power n is equals to twice of all the terms with odd subscript of x. All the terms with odd subscript of x. Alright, anyone is having any difficulty in this? Feel free to reach out to me, kids. There has to be no difficulty at all. So these are the 4 things that we have just seen. So do remember all these things as well. Now talking about a very crucial part. Very crucial part, and that is general term, because your 80% of the JEE questions will be solely dependent on this particular thing, general term. Your 80% of questions coming in JEE mains will be dependent on this particular thing. So in the expansion of x plus y to the whole power n, we see general term, that is tr plus 1th term. Over here, which one is the general term? Over here, the general term is tr plus 1th, not tr. The general term is what? Remember, tr plus 1. And that tr plus 1th term is written as ncr into x to the power n minus r into y to the power r. Let me tell you over here. This is the first term, nc0 into x to the power n into y to the power 0. So in the first term, the subscript of c is nothing but 0. In the second term, the subscript of c is nothing but 1. In the third term, the subscript of c is nothing but 2. In the fourth term, the subscript of c is going to be 3. Yes or no? So in the r plus 1th term, the subscript of c is going to be what? R. Whatever is this subscript of c, will it be going to the power of y or not? Yes, sir. And always the summations of the power of x and y is going to be n or not? Yes, sir. So is this coming out to be r plus 1th term or not? If yes, then we're going to call this particular thing as the general term. We're going to call this particular thing as what? general term in the expansion of x plus y to the whole power n, and it is going to be what? TR plus 1th term, and it will be written like this: NCR into x to the power n minus r into y to the power r. All right. So I hope you guys are clear with this. So if you remember the general term for this, then you can write down the general term for 1 plus x to the whole power n as well, because over here in this formula, if you compare these two, then in place of x, 1 is written, in place of y, x is written. So simply put x as 1 and y as x in this particular formula to write down the general term for this particular expansion. So you're going to get something like this. I hope you guys can feel it. Again, I'm telling you which one is the general term, TR plus 1th term. Which one is the general term? TR plus 1th term. Now understand. In the binomial expansion of x plus y to the whole power n, the rth term from the end is n minus r plus 2th term from the beginning. The rth term from the end is n minus r plus 2th term from the beginning. Understand this particular thing. In a binomial expansion, understand, in binomial expansion of x plus y to the whole power n, rth term from end is equal to n minus r plus 2th term from beginning. Okay, understand this particular thing? Yep. Let's say it like this, that the value of n is equals to 5. Okay. If the value of n is equals to 5, then there will be how many terms, beta? There will be 6 number of terms, n plus 1. So first term will be this. This will be second term. This will be third term. This will be fourth term. This will be fifth term. Sorry, was 1, 2, 3, 4, 5, fifth term. Okay, n's value is 5. N's value is 5. Right? Yep. Okay, over here if you notice, beta, over here if you notice, since the value of n is 5, so over here in total how many terms will be there? 6. Okay. If I tell you this is first term, this is second term, this is third term, this is fourth term, this is fifth term, this is sixth term. So total 6 terms are there. These are first term from beginning. This is first term from beginning. This is second term from beginning. This is third term from beginning. This is fourth term from beginning. This is fifth term from beginning. This is sixth term from beginning. Understand that if I am talking about fourth term from the beginning, then from the end, this is which particular term? Is same as third term from the end. Fourth term from the beginning is nothing but third term from the end, yes or no? If you add these two things, which two things? Fourth term, 4, and third term, 3. 4 plus 3 will become how much? 7. Now understand this. Over here, rth term from the end, that is add this with this. What you're gonna get? N plus 2. Don't you think that over here also 7 is what we are getting and the value of n we have taken is nothing but 5. So if I'm talking about rth term from the beginning, or let's say if I'm saying that if it is kth term from beginning plus, if I'm saying kth term from beginning equal to rth term from the end, rth term from end, then the summation of k plus r will always be equals to n minus 2, n plus 2. Yes or no? Over here I am saying that kth term from the beginning, that is fourth term from the beginning, and is same as is equal to rth term from the end, yani ki let's say third term from the end. So the value of k, the summation of k plus r is what? N plus 2, that is 2 more than the value of n, that is 4 plus 3 is equals to 7. Yes or no? So must remember this. Kth term from the beginning if equal to rth term from the end, then the value of k plus r is going to be nothing but n plus 2. So understand this now. If I am saying that n is equal to 100, okay, and if I am saying that 31st term from end will be equal to which term from beginning? Can you guys tell me which term from beginning? So let's assume that this is nothing but kth term. So the value of 31 plus k has to be equal to what? N plus 2, that is this. So the value of k is what now you guys can evaluate quite comfortably. So this is going to be how much? This is going to be 71. That's it. So 71st term from the beginning will be same as 31st term from the end. So this is important. Keep a note of this particular thing. Now understand, we have seen general term. This general term will be used in so many problems. This general term will be used in so many problems. You will first see it in term independent of x kind of problems. Okay, you will see it in number of rational terms and irrational terms kind of problem. You will see it in some other problems as well. Okay, terms independent of x, number of rational and irrational terms. You will see it in the problem of middle terms as well. Okay, and so many other things. So that's why I was telling you that this is a very important part of your entire chapter, because 80% of the JEE problems will be directly or indirectly connected with this particular thing. So let's talk about middle term. Now let me tell you a concept before I move into this particular thing. Since we know the property that NCR equals to NCn minus R, we know this property. So with the help of this property, we can say that NC0 will be equal to NCn always, NC1 equals to NCn minus 1, NC2 will be equal to NCn minus 2, NC3 equals to NCn minus 3, NC4 equals to NCn minus 4, and so on and so on. This is one of the thing. Number 2, if we talk about the magnitude of all these values NC0 and NC1, then they are at the base. Okay, they are the least values, and both of them are having value what? NC0. I have already told you the value of NC0 is what? The value of NC0 is 1 only. Okay, then the value of NC1 is higher than these two. Okay, then the value of NC2 is again higher than these two. then the value of NC3 is again higher than this. Oh, this is again higher than this. This is increasing values. Increasing values. Increasing values of NCR. Okay. Yes. So this will be equal to NCN minus 4 and so on. So don't you think that if there are some terms written, let's say the value of n is 3. Let's say the value of n is 3. So in total there will be 4 terms. One will be 3C0, 3C1, 3C2, 3C3. So 3C0 will be equal to 3C3. 3C1 will be equal to 3C2 and no more other terms will come. So in that case, out of 3C0, 3C1, 3C2, 3C3, which one are the biggest values? 3C1 and 3C2? Yes or no? If I'm talking about, let's say, let me give you an example over here. If let's say I've taken n equal to 6. If I've taken n equals to 6, then the least values are what? 6C0 and 6C6. Okay, then out of these 6 values, 7 values, 60, 61, 62, 63, 64, 65, 66. Okay, 7 values. 60 and 61 will be the 60 and 66. They will be the least values and both will be having a magnitude equal to 1 only. Okay. Then talking about 61 and 65, they will be all equal. And the value of both of these will be what? 6. You can evaluate it by using the formula NCR. Then the values of these two are 6. So we gonna write down 6C2 and over here 6C4. These two will be equal. So the value of this is going to be what? Definitely greater than 6. Okay. Then moving towards 6C3, the only one term remaining. So out of 60, 61, 62, 63, 64, 65, 66, which one is having the greatest value? 63 is having the greatest value. Then 62 and 64, then 61 and 65, then 60 and 66. They are both equal. Right? Understood everyone? Anyone is having any difficulty in this part? Do let me know. So understand over here that if n is even, then n plus 1 number of terms were there, which means that total number of terms will be odd. Yes or no? If n is even, then total number of terms will be what? N plus 1. So if n is even, then n plus 1 is going to be odd. Okay. And whenever odd numbers are there, don't you think that one term will be highest? One binomial coefficient will be highest. One binomial coefficient will be highest. Only one binomial coefficient will be highest or greatest. Yes or no, beta? Like for example, n equals to 6. So we have seen that 6C0 and 6C6, they will be equal. Then 6C1 and 6C5, they will be equal. Then 6C2 and 6C4, they will be equal. And at the end 6C3 will become. So this is the only one binomial coefficient which is the greatest one. Yes or no? Because n is even. Okay, if we talk about n is equals to, if n is odd, then total number of terms n plus 1. Okay, this value is going to be even. Like for example, if we take n is equals to, let's say 7. So we're going to write down first 7C0 and 7C7, they are both equal. Then 7C1 and 7C6, they will be equal but greater than this. That's why I'm writing it like this, so that your mind can pick up the design. This is 7C5. Then these two are equal, 7C3 and 7C4. Any other term will come? No, sir. So these two will be two middle terms and also greatest binomial coefficients. Binomial coefficients are what? NC0, NC2, NC3, NC and so on. So these are the greatest binomial coefficients. We have seen the flow already. Okay. So there will be two middle terms in this case, and also the greatest binomial coefficients, okay, will be 2 in number. Over here only one binomial coefficient will be greatest and only one middle term. Okay, so you must remember this, number one. In case you want to always find out the middle term by using a formula, then you can use this formula. If n is odd, then number of terms will be n plus 1, so total numbers will be even, and if even numbers are there, there will be two middle terms, as we have just seen. So I don't think that you should remember these formulas, but in case you have confusion, then you can definitely remember these formulas. Otherwise these are very easy to understand. Okay, let's say if n is equals to 11 is there, if n is equals to 11 is there, then there are total 12 terms. Okay, if n is equals to 11 is there, then there are 12 terms. Okay, so let me write down the 12 terms: t1, t2, t3, t4, t5, t6, t7, t8, t9, t10, t11, t12. Now if I want to find out the middle term, I can remove one from here, remove one from here, then remove one from here, remove one from here, then remove one from here, remove one from here. Okay, then remove one from here, remove one from here, remove one from here, remove one from here. Don't you think that you are left out with two middle terms? Two middle terms, and this always happens whenever n is odd, because whenever n is odd, the total number of terms is going to be even, and if even number of terms are there, then these two terms are going to be the middle ones. So T6, if you want to write down the general term, the formula for general term is TR plus 1, that is NCR into x to the power n minus R into y to the power R. Okay, if you want to write down the T6 term, then the value of R is going to be nothing but 5. Okay, so it is going to be NC5, that is over here n is equals to 11. So the middle term is going to be what? The middle term is going to be this 11C5 x to the power 6 into y to the power 5. If we talk about the seventh term T7, so for that we need to put R is equal to 6. And n is already 11 in the problem. So let me write it down. It is going to be 11C6 x to the power 5 into y to the power 6. Over here, the binomial coefficients of the two middle terms are equal. These are the binomial coefficients. So these binomial coefficients, these are the binomial coefficients for middle terms. These are binomial coefficients for middle terms, and that's why they are equal, and that's why equal. You can also feel it through the property NCR equal to NCN minus R, that these two things are equal. So you must remember this as well. I hope you guys are clear with this, everyone. Now let's talk about basic properties of binomial coefficient, okay, or some important results which we must remember. Important results related to binomial coefficients, okay. Number one, that NC0 plus NC1 plus NC2 plus NC3 till NCN, this is equals to nothing but 2 to the power n. The proof of this lies in this particular formula. 1 plus x to the whole power n is equals to NC0 plus NC1x plus NC2x square plus NC3x cube and so on till NCN x to the power n. Yes or no? If in this we put x equals to 0, put x equals to 1, then we can see that over here it will become 2 to the power n, and over here it will become nc0 plus nc1 plus nc2 plus nc3 and so on till ncn. Yes or no, everyone? Okay, this is formula number 1. Number 2, nc0 plus nc2 plus nc4, that is the terms binomial coefficients with even subscript, till nc6 and so on, will be equal to nc1 plus nc3 plus nc5 plus nc7, that is equals to binomial coefficients with odd subscript. And this will again be equal to what? This will all be again equal to 2 to the power n minus 1. Why? Because you can understand, let me give you this particular thing first. If inside this, if we put x equals to minus 1, then over here on the left hand side it will become 0 to the power n is equals to nc0 minus nc1 plus nc2 plus n minus nc3 and so on. Now you can feel that if we take these terms nc1 onto the left hand side, nc3 onto the left hand side, the following result will come till here. And if we call this particular thing as, let's say, t, and this will also become t, so t plus t, 2t will be equal to nothing but 2 to the power n or not. So 2t equals to 2 to the power n means t will be equal to what? Will it be equal to 2 to the power n minus 1 or not? So that's why this formula comes into the picture. That is nc0 plus nc2 plus nc4 plus nc6 and so on will be equal to nc1 plus nc3 plus nc5 plus nc7 and so on, and that is equals to 2 to the power n minus 1. These are some more basic results which you need to remember. Basically this is nothing but 1 into nc1 plus 2 into nc2 plus 3 into nc3 plus 4 into nc4 and so on till n into ncn. The value of this is equals to n into 2 to the power n minus 1. This is the formula, we can easily derive it. Let me tell you the derivation of this as well. There are multiple ways in which we can derive this particular formula. Let me tell you this one, x plus y to the whole power n is equal to, or you can take this one, 1 plus x to the whole power n. We know the formula is equals to nc0 plus nc1x plus nc2x square plus nc3 x cube and so on till ncn x to the power n. Now if you differentiate this, I hope you know the differentiation, you might have studied this in physics. So if you differentiate on both sides, then on the left hand side it will become n into 1 plus x to the power n minus 1, and on the right hand side the differentiation of this is going to be 0. The differentiation of this is going to be nc1, that is the constant term only. The differentiation of this is going to be nc2 into 2x. The differentiation of this is going to be nc3 into 3x square and so on. You're going to move till the differentiation of this will become what? ncn into n into x to the power n minus 1. If you put x equals to 1 in this, you will get the desired formula. That is n into 2 to the power n minus 1 will be equal to 1 into nc1 plus 2 into nc2 plus 3 into nc3 and so on till n into x to the power n into ncn. Right? So this is what the formula is. Okay, if we talk about the second one, then the second one can come similarly, but here we need to integrate rather than differentiating. Okay, so you must remember this result as well. By the way, let me tell you briefly on the second part as well. Second, sigma ncr divided by r plus 1, where r is going from 0 to n. This expression is equal to what? This expression is equal to nc0 upon 1 plus nc1 upon 2 plus nc2 upon 3 plus nc3 upon 4 and so on till ncn upon n plus 1. let me derive this expression for you people as well. 1 plus x to the whole power n will be equal to nc0 plus nc1x plus nc2x square plus nc3x cube, and so on till ncn x to the power n. So if we integrate this particular side, integrate both sides, I hope you have learnt a bit of integration in class 11th in physics. So it will become 1 plus x to the whole power n plus 1 upon n plus 1, and this will be equal to what? nc0 into x plus nc1 into x square by 2 plus nc2, this is a constant, times what is the integration of x square? It is x cube by 3. What is the integration of this? nc3 is a constant, will come as it is, and x to the power 4 by 4. So and so on. If you proceed, then what you're gonna have is this particular thing. Right, over here put x equals to 1. The moment you put x equals to 1 over here, you will get this particular formula, and you need to solve GP as well. So 2 to the power this upon this will be equal to nc0 plus nc1 upon 2 plus nc2 upon 3, and so on till what? Till ncn upon n plus 1, right? So you must remember this particular thing as well. I don't think that there will be any difficulty in order to remember this particular formula as well, everyone. Yes, so okay, plus c will also come. Wait a minute. Okay, so the integration of this particular thing is what you are doing. If then it is going to be something like this, and then nc0 something like this will come. So from here you can have an idea quite comfortably. Yep. Yeah. So that is there. Okay. So in this fashion you guys can prove this result. There will be no difficulty at all, and this formula is very important, the third one. Let me elaborate this. You can if the value of r is equals to 0 given, then this is nc0 into nck plus nc1 into nck plus 1 plus nc2 into nck plus 2, and so on. This will go. Okay, you can take the value, any value of k over here. Let's say k equal to 1, k equal to 2, k equal to 0 as well. Okay, if you take k is equals to 0, then this important result will come, this one. If you take k is equal to 0, then this important result will come. So like this you can remember this result as well. And if you take k is equals to 0, then this formula will come. This is the same formula, k equals to 0. Okay. Yep. So you must remember all these formulas as well. Now talking about binomial, now we have seen binomial theorem, so it's time for multinomial theorem. Let's understand this as well, multinomial theorem. A lot of guys are not able to understand this multinomial theorem, but it is not difficult at all. If you listen to my words, then I think you can definitely master this topic as well. In the binomial theorem, what we have seen so far, that x plus y to the whole power n is equals to nc0 plus nc1x plus nc2x square plus nc3x cube, and so on. We go till ncn x to the power n. Yes or no? Alright, in the multinomial theorem, what happens? In place of two terms, we have more than two terms. So let's say we are having something like this, x1 plus x2 plus x3 plus, and so on till xr. Okay, or rather let's take xk to the whole power n. These are k terms written over here. Okay, first do let me know, can we write down this particular thing also like this? Sigma n factorial upon r factorial n minus r factorial x to the power n minus r into y to the power r. This is our general term, and from here we are taking r equal to 1 till r equal to n, the summation. Yes, if you know this thing, then over here you need to observe a few things, that whatever is the power of x written, the very same factorial is also written over here. Whatever is the power of y you have taken, the very same factorial is over here as well. Okay, and this is NCR only. I hope you know the formula. NCR is n factorial upon r factorial times n minus r factorial. Okay, and over here the summations of the power of x and y is nothing but equal to n only. So over here also we're going to write down the similar formula. Let me tell you, Number 1, over here n factorial will come, something will come in the denominator. The power of x1 is going to be something, the power of x2 is also going to be something, x3 also going to be something, and like this we are having xk, that is k number of terms. Over here, let's say the power of x1 is a, the power of x2 is b, the power of x3 is c, and so on, and let's say till like this if you go, and you are having some power m, then all these factorials will be written over here as well. All these factorials will also be written over here. Okay. Whatever the powers of x and y were written in the binomial theorem, the very same factorials were written over here as well in the formula NCR. So NCR is nothing but n factorial upon r factorial into n minus r factorial. So whatever is the power of x1, x2, x3, xk, and so on, all those factorials will be written in the denominator. And over here, the summations of powers of x1, x2, x3, x4, and so on till xk is equal to nothing but n always, like over here. That's it. If you can understand this analogy, then I don't think there will be any difficulty at all, right? So let's say if x plus y plus z plus w to the whole power, let's say 5 is asked, then this can be written as sigma 5 factorial. Then x will be holding some power, y will be holding some power, z will be holding some power, w will be holding some power. These are, let's say, a, b, c, d. So their factorials will be written over here: a factorial, b factorial, c factorial, d factorial, and the value of summations of a, b, c, and d will be what? It will be equal to 5 only, always. So this is what multinomial theorem is all about. Multinomial theorem. Over here, let me tell you a few important points. Number 1, number of terms. Let me give you the formula over here. Number of terms in this particular thing is equal to how much? N plus k minus 1 c k minus 1. N plus k minus 1 c k minus 1. K means what? Number of terms written over here. x1, x2, x3 till xk. So n is what? This power. K is what? Number of terms written over here. So in this binomial expansion, how many terms will come? They will come by using this formula, and this formula we also known as Bagger's formula. Remember Bagger's method, which you have learnt in permutations and combinations? Bagger's formula. Okay. Yes. So over here, if you apply this formula, then the value of n is 5, the value of k is 4. Minus 1, c4 minus 1. So this is going to be how much? 8c3. So this many number of terms will come. So this will be equal to this. 56. Okay. Yes. This is number 1 thing, that is number of terms. Alright. Talking about this, the general term in the expansion, I hope you guys are clear with this. And let me tell you over here, let me tell you one very important thing, that the values of a, b, c, d are what? The values of a, b, c, and all these are some whole numbers. 0, 1, 2, 3. Whole numbers between 0 to n. Okay, between 0 to n, including 0 and n as well. Okay. Yes. So the general term, I hope, is clear to you guys. The total number of terms, the formula is clear to all of you guys, and sum of all the coefficients can always be find out by putting all the terms equals to 1 only. Okay, so you must remember this as well. And now binomial theorem for any index. This particular concept is what we're going to study. Binomial coefficients, binomial theorem for any index. Binomial theorem for any index. Any index. Index means power. Now, so far, binomial theorem we have seen that the n should be a natural number. But now we are dealing with all these things, 1 minus x to the whole power n, let's say. Alright, let me give you one formula, and based on that we will construct all these formulas. Okay, based on that we will construct all these formulas. Okay, so let me tell you that particular thing. 1 plus x to the whole power n is equals to 1 plus n into x plus n into n minus 1 into x square by 2 plus n into n minus 1 into n minus 2 into x cube by 3 and so on. Over here n need not be a natural number, it can be anything, but over here the most important thing is that the value of mod x should be less than or less than 1. Okay, the value of mod x should be less than 1. Okay, must remember this formula. And if I want to write down the x to the power 4, understand, if over here the power of x is 2, then 2 is coming over here, and also 2 terms n and n minus 1 are coming. If the power of x over here is 1, then nothing but 1 is written over here and only one term n is coming, right? If the power of x is 3, then 3 is also coming here, then 3 terms n, n minus 1 and n minus 2 is coming. So the next term is going to be what? Over here the next term is going to be what? Let me write it for you people. N into n minus 1 into n minus 2 into n minus 3 upon 4 into x to the power 4, and so on this will go. I hope you got the trend. You got the trend. Whatever is the power of x, the very same number is written over here, and those many numbers are written over here as well, starting from n, going one down always. Okay, so this is one formula. Based on this you can evaluate binomial theorem for any index, and you guys can apply in the problem solving. Now let's do some problems based on what we have learnt in this entire chapter, the total number of terms in the binomial expansion of this particular thing. Now a lot of guys, when see this particular question, applies multinomial theorem, but you don't need to apply that, because over here these terms are dependent on each other. Understand, they are all having x only, not like x, y, z and w. So over here in these kind of problems, if number of terms are asked to you, then don't apply multinomial theorem. Rather, if you can combine all these terms together, then first try doing that. So over here we can write down the base like this. So this problem can also be written like this. So this is something where binomial theorem can be applied now. So in this, how many total terms will be there? Total number of terms will be equal to nothing but 31. So your answer is going to be D for Delhi. So what am I telling? These terms are dependent on each other. So don't apply multinomial theorem over here, because if you apply multinomial theorem, you're going to get the wrong answer, because the terms will get clubbed over here as well. If it would have been x, y and z, then you would have applied multinomial theorem. All right, the coefficient of x to the power 4 in this expansion. All these kind of questions will bring us to a logic that write down the general term for this particular expansion. So we know that the general term for this is nothing but tr plus 1, and this is written as ncr into x ki power n minus r into y to the power r. So over here this kind of a thing is given to us, x by 2 minus 3 by x square to the whole power n. So in this, if we want to write down the general term, then in place of x we have x by 2, and in the place of y we have minus 3 by x square. Yes or no? So if we write that particular thing down, then it is going to be, n's value is what? N's value is 10, by the way. Okay, so it is going to be 10 cr. In place of x we do have x by 2. So it is going to be something like this, and in place of y we have minus 3 by x square to the whole power r. Yes? Okay, now the question is asking us the coefficient of x to the power 4. So ultimately we have to club all x terms together over here, club all x terms. So the moment we do that, we're going to have something like this, 10 cr into 1 by 2 to the whole power 10 minus r minus 3 to the power r, and x to the power what? 10 minus r minus 2r. Yes or no? Yep, we are having x to the power 10 minus r minus 2r. Yes or no, everyone? Okay, so over here we can see that this is what our power of x is, and what we are looking for is x to the power 4. So ultimately we have to make this 4 equal to that power of x, that is 10 minus r minus 2r, that is equals to r equals to 2. Yes or no? Yes, r equals to 2. So now the question is asking us the coefficient of that particular term. So over here what we need to do is we need to put r equal to 2 in this green underlined portion, because the moment we put r equal to 2 over here, it will become x to the power 4. So the coefficient is going to be this particular thing. So r is what we need to put equal to 2. So the moment we put it, it is going to be 1 by 2 to the power 8 times of minus 3 to the power 2. So it is going to be how much? 45 into something like this, 45 into 9, that is going to be 405 divided by 256, that is A is the correct answer. By the way, this is the recent year JEE mains problem. I hope you guys can solve this one quite comfortably. Okay, so this is what the solution also I have attached for you guys for your reference. You guys can see this. I think the problem is as easy as anything. If the third term in the expansion of this particular thing equals 25260, okay, third term means it can be written like this: 5c2 into 1 to the power 3 into x to the power log x base 2. This is what written in place of y, okay, to the whole power 2, and this is given to me equal to 2560. The question is asking us a possible value of x. I hope you know that 5c2 is nothing but 10. So the question will look something like this now. So this 0 and this 0 cancelled. So we are left out with x to the power log of x base 2 equals to plus minus 16. Now I hope you can evaluate this value quite comfortably. Yes or no? Yes. So once we can take it equals to 16, once we can take it equals to minus 16, but I think x has to be positive only, so minus 16 is not possible, because why x needs to be positive? Because x is coming over here in the logarithm. I hope you guys know that the condition says us that particular thing. So over here I think we can comfortably get the answer. So I think it has to be 1 by 4. Yes, feel it? You can take log to the base 2 both the sides. The moment you take log to the base 2 both sides, this will become 4 and this will come in front. So ultimately the question will become something like this: log of x to the base 2 whole square equals to 4. From here if you solve this, this is going to be log of x to the base 2 equals to plus minus 2, and from here two solutions are coming. One is 4 and another one being 1 by 4. Yes, everyone, have a look at this. This is also a recent year JEE problem. I hope you guys are fine with this. So here is the solution I have attached for you guys. You guys can see it for your reference. Now understand, this is also a recent year JEE mains problem. Is this question based on the thing I have talked about, x plus y to the whole power n minus x minus y to the whole power n? So over here this expression is going to be what? A rational number other than positive integers, or what? So we can write down this particular thing as 2 times of 2n c0 root 3 to the power 2n plus 2n c2 root 3 to the power 2n minus 2 plus 2n c4 root 3 to the power 2n minus 4, and so on. Okay, over here if you see, then NCR is always an integer. So this is integer, this is integer. So the overall thing is going to be integer. This is also integer, this is also integer. So this is also integer. Similarly, this is also integer, this is also integer, this is also integer. So is it going to be an even positive integer because 2 is also there? Yes. Look, if you know this particular thing, you can solve this question in just a matter of few seconds itself. This is a recent year JEE mains problem. If the second term in the expansion of this particular thing, all right, this is the question is written something like this. Let me tell you. A upon a to the power minus 1 by 2. Okay, so this question can be rewritten like this as well: a to the power 1 by 13 plus a to the power 3 by 2. Okay. Yes. Okay. If the second term in this expansion, so can we write down the second terms in this expansion? Okay. I think n is missing. I think n is missing, so that will not let us to write down that value. Okay. Let's say if it is like this, 14. Let's check, because as I can recall, it has to be 14. Okay. So 14c1 times of a to the power 1 by 13 to the whole power 13 into a to the power 3 by 2 to the whole power 1 is what we're going to have. Yes, okay. All right, it is equals to n. This is equals to n. And what we need is the value of this expression. I said okay, so value of n will be equal to 14 only. This is what we can understand quite comfortably. Orally also we can feel this, or if you want to write down the second term, it will be written like this. The second term in the expansion will be written like this, yes or no? So this is equals to 14 into a to the power 5 by 2. Upon comparing, you guys can see that n is nothing but 14. And if n is nothing but 14, the question is asking us the value of nc3 upon nc2. So that is, it is asking us 14c3 upon 14c2. Today only we have learnt a formula. Over here 3 will come, over here 12 will come. So the answer is going to be nothing but 4 only. So this is a recent year JEE mains problem. Understand how easily and comfortably you guys can solve the problems if you know a bit of these very basic things. Yes, everyone. So for your reference, I have attached the solutions as well. Find the coefficient of x to the power 20 in this. I said, all right, can this expression be further simplified? Yes, it can definitely be, because it can be written as x plus 1 by x ka whole square to the whole power minus 5 times of 1 plus x square times of 40. So this expression can be written as x plus 1 by x to the whole power minus 10 times of 1 plus x square to the power 40. Okay, this can further be written as x square plus 1 upon x to the whole power minus 10 into 1 plus x square to the whole power 40. This can further be written as x square plus 1 to the whole power minus 10 divided by x to the power minus 10 times of 1 plus x square to the whole power 40, and this can further be written as 1 plus x square to the whole power 30 into x to the power 10. Now ultimately what we are looking for is coefficient of x to the power 20 in is coefficient of x to the power 20 in this. So ultimately what exactly we are looking for is coefficient of x to the power 10 in this. If we are looking for coefficient of x to the power 10 in this, then can it be written as 30C5? Feel it, the answer is nothing but C for Calcutta. Yes, everyone, and the problem is solved quite comfortably. Yes, I have attached this solution for you guys as well. This is also a recent year JEE mains problem. Alright, here also the similar thing is coming or not. If I call this particular thing as x and this particular thing as y, then the problem is nothing but x plus y to the whole power 5 plus x minus y to the whole power 5. So I know that this can be written as 2 times of 5c0 x to the power 5 into y to the power 0 plus 5c2 into x to the power 3 into y to the power 2 plus 5c4 into x to the power 1 into y to the power 4. If yes, then this very similar thing can also be represented. Now 5c0's value is 1 and x is nothing but x only. Okay, y is nothing but not required over here. Okay, 5c2 is nothing but 10 x cube, and now this will become x cube minus 1 because it is under root of x cube minus 1. So square if you do, you're going to get this, and this is nothing but 5 times of x into x cube minus 1 ka whole square. So this is what we're going to get. The sum of the coefficients of all odd degree terms, First we need to separate all odd degree terms. So over here we guys can see that this expression can be rewritten as 2 times of x to the power 5 plus 10 into x to the power 6 minus 10x cube. Okay, and over here if you do the expansion, then this particular thing will be what? This is going to be x to the power 6 minus twice x cube plus 1. So if you multiply this with 5x each and every term, so it will become 5 into x to the power 7 minus 10 into x to the power 4 plus 5x. Okay, so can we identify odd degree terms from here? Can we identify odd degree terms from here? This is 1, this is another, this is 1, and this is this. Okay, so if you see the odd degree terms, if you see, so it is going to be 2 into x to the power 5 minus 20 into x to the power 3 plus 10 into x to the power 7 plus 10x. So if the sum of coefficients is asked, then what you do, you simply put x equals to 1. That is, you simply put the variable equal to 1. Put x equals to 1. So the moment you do this, 2 minus 20 plus 10 plus 10, the answer is coming out to be 2. So the answer is option A. This is also a recent year JEE mains problem. If you follow the things that I have told you in this lecture, then I think you can solve these problems in a relatively very easy manner, kids. Yes, the coefficient of x to the power 7 in this particular expansion. The coefficient of x to the power 7 in this particular expansion. Can you guys solve this particular thing? Everyone have a look at this particular thing. 1 minus x square we can separate, and over here we can take x common. We're gonna have something like this. Okay. Yes. So this very same problem can also be written like this. 1 minus x square times of 1 minus x to the whole power 6, yes or no? Yep, okay. This same problem can also be written as 1 minus 1 plus x times 1 minus, okay, 1 plus x into 1 minus x. So 1 minus x ka, oh, this is 6 and this is power 12. This is what we guys can write down. Okay, the coefficient of x is what we want to find out, the coefficient of x to the power 7. Okay, this is what we have written because we can write down this thing as 1 plus x into 1 minus x. Yes. So the question is asking us the coefficient of x to the power 7 in 1 plus x to the whole power 6 into 1 minus x to the whole power 12. So over here you need to understand that if you expand this particular thing, then it is going to be what? 6c0 plus 6c1x plus 6c2x square plus 6c3 x की power 3 plus 6c4 x to the power 4 plus 6c5 x to the power 5 plus 6c6 x to the power 6. Okay, times over here if you see it is going to be what? Over here it is going to be 12c0 minus 12c1x plus 12c2x square and so on is what you're going to have. Minus 12c3 x की power 3 plus 12c4 x की power 4 minus 12c5 x की power 5 plus 12c6 x की power 6 and so on. I'm not writing down the other terms. Why? You will get to know. We need to form x to the power 7. We need to form x to the power 7 means if this is what we multiplying, we have to multiply this with x to the power 7 only. Okay, so we need to write down this as well. Okay, so we need to write down this as well. Minus 12c7 x to the power 7 and so on also. So when you multiply these two red things, this one and this one, you're going to get x to the power 7. So you're going to have 6c0 times of minus 12c7. Okay, this is one of the term. If you multiply this, then you have to multiply this with what? You have to multiply this with x to the power 6. Then over here it is, okay, so this is going to be this into 12c6. Okay, this if you are multiplying, then you have to multiply it with x to the power 5. Okay, so this is going to be 6c2 into minus 12c5. Okay, if you're multiplying this 6c3, you have to multiply it with 12c4. If you are multiplying this 6c4, then you have to multiply it with minus 12c3. If you are multiplying this, then you have to multiply it with this 12c2. If you are multiplying this, then you have to multiply it with this. So this green one is going to be your answer. Okay, so one way is you can simplify it like this and you can solve accordingly. So the value of 6c0, and I think you can apply this one and can get the answer quite comfortably. Yep. This can take a bit of the time, but I think you can definitely do this. So I think now I'm giving you this question as homework because only binomial coefficients are needed to be evaluated now. Okay, I have attached a solution for you people as well. You guys can see it, and there is another way. Instead of doing this one is making a bit calculations, but if you do it like this, then calculations will be sorted out. Over here only we have applied x minus y ka whole power n formula. Okay, this is one more category to find out the fractional part or to find out the remainder. Now in all these questions, our agenda is what? Let me tell you. whichever number by which we have to divide, we have to write down its table. So 28 times 1 is 28, 28 times 2 is 56, 28 times 3 is, you can do it, 84, and so on. You guys can do this, right? Okay, number 1 you have to do this. And also whatever power we are given with, we have to write down some powers of this, like 3 to the power 1 it is equals to 3, 3 to the power 2 it's equals to 9, 3 to the power 3 it's equals to 27, 3 to the power 4 it is equals to 81, and so on. Always you have to do this. What the number by which you are dividing, you have to write down its table, the power of some number to the power, anything is given, so write down its power for a few terms. Okay, now you have to choose one term from here and one term from here in such a way that the difference between those two terms is nothing but equal to 1. You have to choose one term from here and one term from here in such a way that the difference between those two terms is nothing but equal to 1. So you can choose this and this, yes or no. Okay, this is what you have to keep in mind always. If you are done with that, then ultimately you have to see 3 to the power 2003 when divided by 28, what's the remainder? This is the question. What's the remainder? This is the question, right? Okay, so what you do is, you take this expression 3 to the power 2003 divided by 28, you write that particular term 3 to the power 3, 27 that is. Okay, the moment you do this, now it will become something like this. Yes or no? The moment you do this, you have to always notice that is this number a natural number? Is this a natural number? Is this a natural number? No. If it is not, then you will not proceed like this. If it is not a natural number, then you will not proceed it like this. Rather, what you'll do, you will do some small change. What you have to first find out which number is exactly divisible by 3 just before this power 2003. So the number is going to be 2001. So rather what you will do is you will first write down the given question like this. Why we have taken 2001? Because just before this 2003, which number is divisible by 3? 2001, that's why. Okay, the moment you are done with this, then in this particular thing, you're gonna do something like this. Okay, and this particular thing can further be rewritten as, this is 27, so 27 can be written as 28 minus 1, and raised to the power how much will come? 6 3 the 18, 20, 6 3 the 18, and 7 divided by 28. Now in this particular thing, what you're going to do is you're going to apply the binomial expansion. So if you apply the binomial expansion in this particular thing, you're going to have something like this. Let me write it over here for you people. 667 C0 27 to the power 28 to the power 667 plus minus rather 667 C1 28 to the power 666, and like this terms will keep on moving. The second last term is going to be 667 C666 28 to the power 1, and the last term is going to be 667 C667 into 1. Okay, yes, this is what going to be, and in the denominator 28 will come. Now each and every term, this will be divisible by 28, this will be divisible by 28 because 28 is coming till here. Only that last term will remain, so that is nothing but equal to 1. So over here minus 1 is left out, and over here 9 is there. So minus 9 will be the answer? No. Remainder can never be negative. Whenever negative remainder is coming, just add the number by which you are dividing. So your answer is going to be what? Minus 9 plus 28. That is equals to 19. So the fractional part is going to be nothing but 19 by 28. B for Bombay is the correct answer, kids. Now whatever I have told you in this particular question, if you have made a good command on that, I think you will be able to solve each and every question coming from this particular portion, and I have attached the solution for your reference as well. All right, now you will be doing this particular question as part of homework. Do try this question, and also don't forget to solve the DPPs as well. They are also available in the app itself, which are completely free. Do try to solve this question as well. Do try to solve this question as well, and a few more questions I will be giving you as part of homework in the DPP, so do solve that. I hope you have learned something out of this session, and whatever the things that I have mentioned in this session, if you are taking care of that, then you can make binomial theorem as a relatively way easier topic for you all as well. See you all in the next session. Keep learning, keep shining, keep rocking, keep enjoying. Let's make most out of this. Thank you so much.